All right, so all right, so what I'm going to do today is probably going to be a little bit different. What I want to try to do for once is so this is kind of our original approach that we use that works really well. And I think that the only real problem that we were running into here is that I actually don't think this is going to work. And it's not going to work because, let's see, I think we need to do. Yeah, this is, okay, so one of these tricky things is that I got to look at function that works with quaternions, and it seems like it works for the most part, except for it puts me at the wrong angle. It puts me flipped on the other side. And I don't think, yeah. So, oh, the other thing was maybe I could use negative position, but I don't think this. I don't think that's well. So here's what's weird about that. Our rotation for that object is actually just a Y rotation. So so that's completely wrong. So anyway, a lot of the stuff that I added just isn't actually working. I was hoping that would be good, but it's not. And this one actually isn't bad, I don't think. But this one, actually, this one didn't even give me anything. Yeah. So yeah, a lot of these I'm not really quite sure why that doesn't work, but it doesn't. So I'm gonna keep these just kind of here, just to keep them there. But what's up, Killer George? How's it going, man? So I'm actually just considering, really at this point, just doing this sort of thing. Because I actually think this was fine. So let's see here. So I could do this. Matrix 4. And to look at, yeah. And we do position, target, up vector, and our rotation ends up being turning in from rotation matrix. This is a little bit backwards, to be honest. We're just mostly going to test this out right now. Actually, we would just do this. Transform as matrix. Look at. And it would be position, target, up. And our rotation is going to be, we're going to pull it from the rotation matrix of the transform, but then we also have to rotation matrix is equal to, and I think this might be a little bit more work, but it's going to pull it from the rotation stuff. All right. Is it still flipping it? Kind of is. Yeah, it's flipping it back and forth. No, it didn't. After I turned it off, after I turned off the thing, no. It didn't, but I couldn't move swamp, so it didn't matter. I sucked. For like 4 runs in a row, I sucked. So I just stopped. Let's see. Let me look at the history here. Let me compare these two. Okay, yeah. This is what I want to get again. Because this was actually doing what we wanted. Oops. I need those lines. Whoops. Wait. Let me look at that diff again. Hold on. Just gonna get the whole thing. That way I don't miss a piece. For our camera though, I think we wanna apply something a little bit different. And we're gonna actually add it directly. Let me make sure this is good. Yeah. So we're back to our regular being able to move around and stuff. So this is not perfect. And in fact, I just really actually don't like this at all. But I wanted to briefly talk about it. And until I restarted last night, I had a really good reference to a maybe it's this. Maybe it is this. Hold on one second. Turning utils. Okay, yes, this. Sorry, I have a I want to see if this is the same thing actually. Sign horizontal. Okay. So basically I have a I have an approach that I want to use, but let's look at it let's look at it like this, because I want what I really want to do is on the camera object I need this I want to add something called what do I want? Yeah, see, I think the biggest problem with this is that okay, we'll just do apply. We'll do follow mouse. And this is not where we're not going to call it. We're actually not going to call this or actually we'll just call this update mouse. And mouse view is what we'll call it. And it's going to take a float pitch and float y'all. And essentially what we want here is it's gonna create like a look at but I need to figure out exactly how to so the first thing we have is this is basically gonna take our mouse input and it's gonna put it sort of in like a spherical Cartesian coordinate. And then that's gonna map it's gonna create like a sphere around our mouse, and as we like move around, it's gonna be able to determine how it should rotate the camera based on where that projection happens, based on our mouse movement. Give me a second, because I'm actually surprised that I've wasted so much time on this, but again, it's also not super straightforward. So we'll take the cosine of this guy, pitch. It's got to be radians. We'll do sine pitch. Angles float. That sine pitch. And we'll do cosine y'all. Float. That cosine y'all. And then sine y'all. This is just to kind of go ahead and get the value, so we're not having to apply these math functions every time we use the values. Kind of like an optimization. X-axis is going to be cosine y'all 0, negative sine y'all. Vector 3, y-axis, new vector 3. Sine y'all times sine pitch. Cosine pitch, cosine y'all times sine pitch. And then vector 3 z-axis, new vector 3. And this is sine y'all times cosine pitch. Negative sine pitch, cosine pitch times cosine y'all. And then what we're going to do here is kind of cheat a little bit, and we'll do our transform is equal to, oh, I wonder if we wanted our rotation. That's annoying. Oh, we'll try it anyway. And this is going to be, I think you can do X axis 0. Vector for y axis 0, 0f. New vector 4. I could probably just make these vectors up here. I'll do that in a second if it works. And then 0.0f, and then new vector 4, and this is going to be negative position and 1.0. And I assume we should update the dirty flags after this, actually. So let me make those available. Protected. A lot of this stuff just needs to be protected. Excuse me. And we'll do dirty and equals not dirty flag dot rotation or what's up? How's it going, man? Let's see if this gives us anything like what we would hope to get. Let me okay. So these two angles that I'm going to pass to this thing need to be between 0 and 90. Yeah, these two right here, and this needs to actually be between 0 and 360. But this is essentially going to give me like a rotation percentage. So let's see. So these are all in radians still. So we want to try to. Where's our update? Right here. So let's see what this let's see what happens here. Update mouse view, and we'll do look rotation X and look rotation .Y. This is the biggest problem that I have here is that I can't see anything. So it's very hard to debug this. But I can also try to do this too. Outlines of what? Yeah, I could do like a skybox or something, but that's jumping ahead quite a bit. But outlines of what? Like I think the problem here is that I'm gonna copy this straight out of this example that I found here. But this is gonna be our vertical angle. This is gonna be look. Okay, let's just do that. Let's do it like this. So we'll do vector 3 direction equals new vector 3, and we'll do float math that cosine look rotation at y times float math that sine, and then look rotation at x. I may have these flipped. And then float, and then cosine rotation at y times method sine horizontal look like this. Okay. So this is what's different here is that instead of using this forward direction, this is actually going to be my forward direction. Oops. And actually to get up, we also need a right vector. So we'll do this. And this is going to be the same sort of thing. Vector 3 right direction equals new vector 3. And we're going to do all this crap. Float. Wait, what was that? Was that a sign? Yeah. Rotation at x minus, interesting, pi over 2, 0, and then, wait, this is cosine, wasn't it? Yep. And then look rotation x minus pi over 2. Okay, so it's right. And then our up direction is going to be vector 3. Up dir is going to be the cross product of right dir and forward dir. So instead of actually doing that mouse look at thing, this is what we're going to do. We're going to do look at, we'll do main camera look at, and we'll do the target as being main camera position plus forwarder and our upder. No idea if this will work. Yeah, I think it's going to end up being that we have to do Oh, actually, I think this is a flipped coordinate system. Shit. It is, but I'm not smart enough to figure out how to. Okay, hold on. I mean, the thing is once we get this right, we never have to do it again. The biggest problem with all of this stuff, just so it's clear, is that all of these, anything you can look up on the internet, anything you can find examples of this, almost everything unexplainably uses different coordinate systems, different y ups, different z values for forward directions. Like the math has small, minute changes. But the problem is that if you change the math slightly, it completely alters your results. Like you get completely different things. Like we can't use anything that flips the y the up direction to negative. So hold on. We're gonna figure this out. Even if we have to like open up like Unreal or Unity and tinker around with what they do, we're gonna figure this out. We want to be able to move our mouse like a FPS camera. That's really all we want to do. Maybe, I don't know if I have Unity installed, but yeah, I do. Let's take a look. What's up, man? How's it going? So let's just open Unity. I am lost, dreadfully lost. super stuck. The math is killing me here because the thing is I'm prepared to I don't think that I have an account here, but let's yeah, it said invalid email. Why do I have to sign in anymore? Maybe I just have to create one. Hold on. So my problem is that I don't know how Unity and some of these other how they do this flawless. Like the biggest problem is that I'm using lookat to kind of control how my transform is created. If that makes sense. So basically, I use like an internal rotation matrix to figure out basically any rotations that I've applied, and then I use that rotation matrix to find my forward vector and my up vector. And then from there, I can use a lookat matrix using the forward and up directions to create my full transform. But that also seems kind of redundant because if you have a rotation matrix, like really all you should have to do is just apply the rotation matrix. But anyway, that's beyond the point. I think what my biggest problem is that I'm working on like trying to get I'm working on trying to get the camera to actually follow the mouse here. And I'm actually not far behind, but I have axes that are flipped and it's driving me crazy. And I can't figure out where my math is wrong that's causing the problem. Like, so I can, at this point, I can find all of this stuff. Let's not do lookat. We can do this main camera dot rotate X. This is, let's do look rotation, I think Y, and rotate Y, and then look rotation X. I think this is what I had. That's all right. The other thing is I don't have enough scenery. And so I really think what I'm going to end up having to do is somehow what I actually could do that probably wouldn't be too expensive is draw the axes. Is draw like a X and Y and a Z axis maybe. Here, let me find something quickly for that. So how do we do this? We would need, let me do this. I think I need we don't want light. We just want like a straight up, just lines. We just want rays pretty much. So I think really all I need is let's do that. I think this is going to be worth the effort, and I think that it can probably help us. Oh, no, that's not what I wanted. All right, at this point, we just want vec3 color. And I think we can just do out. Or we'll do out vec for frag color. And we'll just do this and this. This will be our frag shader. We'll just do I'll just do axis frag, and then we can probably just make this kind of condensed. And then we want a public static string. We'll do axis vert equals. So we're gonna write a new shader because we don't want our axes to like pass through our complicated shader above. So we're just gonna create like a new quick and dirty. Oops. Void main void. I think we only want in position from all these. Oops. It's frag shader. We probably could use that though, but it doesn't really matter. We don't even need to pass this. Also, 1 second, I was creating a... Oh. Oh, did it send me? Give me a second, guys. I'm sorry. Trying to do too many things at once. Okay, there we go. It's asking me all these freaking questions. Mac, Linux, Web, Windows, Xbox One, games. Okay. You're welcome. Okay. Settle down there, Sandy. Since when did all this crap become... I think all we need here is literally this. In position, and we just got to come up with some general... I'm trying to debug, so... Let's see. Are you kidding? There we go. Sorry, I'm working off screen. I'm trying to get vertices here for the axis values because I don't want to think about them. Vertices. Vector 3. Actually, we need to make it a lot longer than just regular ones. Well, I went to 4-year university, so not really that long. What if we I've been doing it for a lot longer than that though. If that's any consolation. Since since I was 11, I think is when I like started, like with the very basic.
Come on,
stuff.
kill me, I'm here.
Thank you for that follow. So we just really want to draw lines, and I am drawing a blank. I think for the most part, you end up having to do like a quad. I think I'm going to actually have to do a full quad. For a line. I'm actually realizing that that's a pretty difficult and annoying problem. Okay, so I guess that's what we're going to do though. We don't need this shader now. So this is what we're going to do. We're going to create 3 more renderable objects. And we're going to call this x-axis, y-axis, and z-axis. And we're just going to render them as quads. I screwed this up. I think I do want that rinky-dink shader. So let me. I copied that. Let me add this back. Then we add these back, and then I have one more shader program called. We'll just call this simple. And simple. Let me locate. Okay, here we go. And we'll just do shader program, and we'll do a new ray shader. And simple will be equal to a new shader program. And what did we call this? I think it was rave. What do we call those? Damn it. Axis vert and axis frag. Oops. So axis vert, axis frag. Pass in our fragment and vertex shader. We'll do this as well because this is helpful when there are errors. And for this, we only need to set nothing about the light and we only need to set color, and we'll set it to like bright ass red. And then we can return shader. All right, so let's see where this is. This is the program. Okay, so let's create something that returns. We're going to want it to return a list of VAOs, vertex array objects. Each of those is going to have a list of vertices that build a quad for each one of our X, Y, and Z axes. So new axis quads, and we'll create that shader and we'll set it to simple. It will do new, what do we, axis shader? Axis quads? No, new ray shader, whatever. It's not a very good name. I can change that later. And we want our I think we can just render these things straight out. We don't actually even we'll see. So what we'll do here is we'll create, so x-axis VAO is going to be equal to this geometry. We're going to use this geometry tool, create quad. And we're going to pass it the simple program. And the location is basically where it starts. And so what we wanted to, we want this first one to start at let's see, this is the x-axis, so it needs to start at -1. No, we wanted to start at negative. This is x, so -100 and 0. And we want the size to be in width. Oh, this is annoying because I don't want to just create an up and down quad. I actually want to create a quad in 3D space. Maybe we should do a cube instead. Let's do that. You know what? It's going to be kind of expensive, I think, but I don't really care because the whole point in this is to debug. So let's do this. Let's create a cube. Let's do the minimum here. Yeah, I'm not actually using Unity 3D to write any of this. This is all going to be OpenGL. It's going to be direct bindings on OpenGL. It's not going to be any we might use Unity to kind of like look at some things that they do there to kind of try to figure out some of the math. I'll be honest, I don't think you need any sort of super in-depth knowledge about trig and linear algebra is the big subject matter that applies everywhere in this sort of stuff. But you know, I got a math minor. I studied a lot of linear algebra and the like, and I forget it almost as fast as I've learned it. So I'm a principal engineer at NCSoft in the U.S. Studio is in San Francisco, San Mateo. And I do mostly back-end server-side stuff. Mostly. That's about the limit of what I can of what I can talk about in terms of my day job. But we do a lot of this stuff. I'm way out of practice. Yeah, Guild Wars 2, and they're primarily a South Korean company, but they've opened studios in the US recently, trying to grow and expand. And I really enjoy it. It's a really good culture, really good company. I really enjoy working with them. Let's see. So we're gonna make these cubes, and we're just basically gonna stretch these things, and we're probably gonna get a bunch of warped looking weird oddities coming from it, but it'll be okay, because again, we're just using this to kind of debug. So let's pass it to Simple Shader. Let's create this vector 3. We want this is basically going to be our minimum point, which is we're going to say is going to be -100 on the x-axis, and we're going to drop it down below the y-axis just a little bit, and we're going to bump it out a tick. And I almost want to make this 0.5. And then our max is going to be 100, 1.0f, or 0.5f, and 0.5f for the Z2. So what that's going to actually do is create an array. This is a nice little helper that creates, we can't see it. It basically creates a vertex array object, which is just a bunch of little vertices that we're going to be able to upload to our shader and render it, and it just, well, hopefully, you know, I was making a lot of progress, and I think it was very informative for a while, and then I started hitting some snags where a lot of this stuff was completely unscripted. I don't do any sort of like preparation. I just start streaming, and then I hope to accomplish things and like maybe share and get into some valuable discussions. But what's ended up happening is that I actually started running into problems, and I think it's important for people to see developers with experience suffer from problems, because I think there's myths of a unicorn type programmer. I mean, there's no such thing. It's like everyone experiences hang-ups and bugs and issues, and I think it's important to kind of show that that's the case. But again, I'm trying to be productive here, and I want to make progress so that it's informative and helpful. And so I really probably should spend maybe half a day of my own time just to kind of figure out how to get out of the hole and kind of move forward with progress. And so part of this today is just going to be kind of, so we've hit a hole. We really need to figure out a way to determine what our problems are. And right now all we're doing is we have basic structure down and a good solid render pipeline. We're just trying to, the problem we ran into is that we want a FPS style camera where we can WASD to move forward, and that's all working. The keyboard. It's when we hit the mouse. We want the mouse to be able to be our look, so we can look around freely with the mouse, and it's not working correctly, and it's really hard to debug because all we have is a single object in the middle of black space, and it's like you can't really figure out what's going on here. So that's what we're going to try to do today. So this is going to be our -0.5f, and so what we're going to do is we're going to create the X, Y, and Z axis, so when we're looking around, we're going to be able to see, we'll be able to tell, like, actually what the problems are. Like we'll be able to see where we're actually looking because we'll notice on the axes kind of our position, our relative position. If that makes sense. I hope it does. I think it does. Negative and then negative 0.5f and then new vector 3. What is 0.5f, 100, and 0.5f. And so these are just basically going to be giant stretched out cubes because I'm pretty sure that based on some of my reading, and I seem to remember something like this. I've done some stuff with Unity before with drawing lines, but believe it or not, lines in OpenGL and our drawing lines is actually really difficult with a 3D rendering system. Especially like 3-dimensional lines. That's what I mean. Not like UI and flat 2D surfaces are not hard to necessarily project 2-dimensional stuff on, but when you start talking about a line drawing through 3D space, it can be difficult. So this is our last axis. It's going to start at 0.5, negative 0.5, negative 0.5, and then negative 100. And by the way, this 100 value is on our scale of everything. Everything's normally within view of like negative 10 degrees or negative 10 units. So like 100 is pretty stretched out there. And then a 100.0f. Okay. And actually, let's do this. iRenderable. Let's make these renderables because I want to return a new list of iRenderable, and we want it to have inside it x axis. Oh, whoops. No, it needs to be a new OpenGL renderable. Oh, I do need models or my objects for it. Let's see. I'm just going to call this one x-axis. So our render pipeline basically has two things. It has an object representation, which has a lot of transform information, name, some of the control aspects of that geometry. And then we have, and in our case right here, it's going to be nothing. It's basically just going to be an object at rest at the origin. And then we pass it, and then the second component is our geometry. So we have our object representation and our geometry, and that combined is a renderable. Y-axis, and you'll see kind of an example of how we take these renderable things and we pump them into a renderer, and it gives us a pleasant output, hopefully. Okay, so the things we did, basically we create that new ray shader, we create all this geometry. I think I had some, yeah, so these things right here probably need what is it, disposed children, I think. You go to y-axis. So one of the things about working with native bindings, which, to be clear, OpenGL is a native library, and so it would run natively in Windows or natively in OS X. But the biggest problem is when you do something in a managed language like C+ or like C# is that you have to take special precautions when you bind things to your native libraries. In this case with OpenGL, so you have to this binding library I'm using requires you to do some weird disposal stuff in order to make everything happy. And there's one more disposable line I'm looking for here. It was like dispose scene. Yeah. So this is, let's change this to a list iRenderable. axis. And we'll do simple.dispose, and we'll do for each var renderable in axis render. We'll dispose each one of those as well. Dispose scene just happens at the very end when we close the window to the program. So we're almost there. We need to do axis equals new axis quads. That's again not a very good name, but that's fine. What we want and then for each var axis in wrong syntax, we want our renderer to render. So we're just going to loop through each one of these axes that we created, and we want it to render using the main camera. And then we pass in our axis renderable. And that should, of course. Oops. So our shader compile probably failed. That's my guess here. So let's see what the issue is. So here's our debug. Cannot convert vector of vec3 to 4 position vector. Okay. Very easy to fix. This is probably a typo or a miss. Oh, yep, right here. So but actually what we want to do is this projection times view matrix, projection matrix times view matrix times model times vec4 in position. I'm not positive. Yeah, it's still mad. Hold on. Oh, interesting. So no more errors. What is null? What is null here? Do I need a uniform? I think I need a uniform. I need to. Yeah, I do. I need to make I need to make this. Yeah, jeez. I need to make this a uniform vector color or whatever, because it's got, you got to be able to set it from externally. And of course, we're not seeing anything. Let me revert some of it. Let me comment out some of this camera rotation stuff and just see if we can't get, you're going to see actually our light shader in action here. Okay. Hey. So there's our, looks like our Y and our Z axis, but I don't see our X axis. That's weird. I wonder why. It's really strange that we see. That's a whole lot bigger than I planned too. Let's try to shrink it down here. Let's make this like 0.1. Let's make all. Let's just make this a something we can modify. We'll just call this like ink, and we'll call it width, and we'll just do 0.1f. So here, and this will be length, and then that way we can tinker with these values without having to change them in 100 places. So this will be negative length, and then negative width, Okay, and then this will be negative width, negative length, negative width, and this one will be negative width, negative width, negative length. And this will be the same thing basically, length, width, width, and then width, length, width. We're going to make sure this works after this. Let's see, width, width, length. So that's a little better. I'm still a little bit confused as to why our cube is not showing up on top of that. Perhaps let's look at our renderer. Yeah, I'm not quite sure. So if we remove this, is it going to actually draw? Did we break something? Yeah, that's really odd. Let's just try this then. Render, not render. So what you just saw there was our little cube. Yeah, I mean, I'm not being super entertaining at this point. So here's what's confusing is for some reason switching. It's not quite clear to me why rendering the second object is a problem. Because if you notice, we're not really swapping things here. Is it because of the texture? Can't be. Why is this all of a sudden an issue? Like, did you guys just notice that like this should be it's just not clear to me why there. Number one, there's only 2 axes showing up. That's the first mystery. I feel like if I removed one of these, would the other one show up? So that's the y-axis. Something really weird is happening because this first axis isn't showing at all. X-axis VAO. Let's make this 50 and let's make this like 0.05. Let's see what happens there. Same thing. So something something very odd is going on here. And let's figure it out. So it's just for the time being, let's just focus on maybe rendering these. All that's right. I wonder. Let me open up this library because I want to see what it's doing. So when I do shader use, oops. Excuse me. Okay. It might be the case that I need to use the shader before setting these things, but also let me check out VAO draw. ID, geo bind vertex, bind attributes. Draw OpenGL3. Okay, so bind vertex array. We draw elements. That's all we do. We don't. There's no call to. So that's. I mean, that's right. I mean, this is exactly right. So I'm stumped. We clear here. Like, why the hell isn't this showing up? Like, this is confusing. Like, oh, now you want to show up. Maybe that was the problem. Maybe what I just fixed was the problem. Jesus. Okay, then. So, if this doesn't work, I'm just going to throw something. Hooray. Okay, so look. So check it out. So we got... God, I can't believe that was the issue. Anyway. Our X, Y, and Z axis are cube rotating at the origin. Hopefully, now we can take a look at, like, maybe... Let's maybe just try to... Let's just keep this the mouse bound to this. Okay, so this is interesting. My mouse movement here is actually coming out. Why though? Why though? Let's try this. So let me just add a little debug here. And we'll do look.x. Oops. We'll do look.x. And we'll do look.y. And then look rotation.y. I'm curious to what these values are actually showing up as here. Let me pull this over here a little bit. So look y is actually almost always turning up as 0. And even more strange, that x is, why is look y always... Let's go back. Try and pull this up again. Okay, so that looks actually better here. Okay, so interestingly, this mostly looks, it's reversed. That looks pretty, I mean, that looks better, right? Although it's reversed. So let's flip it, because I think that's what we should do. So the reason I called it array. So okay, good. So left, I'm moving right, left, right, left, right, left, right, left, right. Okay, now that looks okay. Now let's remove this, but let's see if we can. Let's see what our X rotation is giving us in terms of, because here's the thing: is our X rotation is kind of our. Okay, so this is at this point it's inverted. Up is down and down is up. So this is where it gets tricky though. Because I can negate that. And now, well, nope, it's still the same. I wonder if this is because of our order? Why is that flipped? I think that is right, but I think that it's flipped. Let's maybe. So let's look at this again. I want to look at these values. So let me get rid of what we had in our update. Let me get rid of this. I'm curious about this. So when we move up, it's creating a negative value. And when we move down, wait, that's actually right. Up is up and down is down. And once we add this back in, what happens? Wait, where the hell did it go? Oh, there. Okay, so how do we get so sideways here? I guess we aren't really sideways. Up, down, left, right. Up, down, left, right. Okay, so this is still wrong because we shouldn't be doing this. Like we should never tilt. We should never tilt one way or the other. Like the way that we're tilting right here, like our okay, hold on. So let's maybe think about this. Why are we tilting? We're only sticking to X and Y rotations. Why are we tilting? I'm getting the sense. Yo, what? Okay, not exactly what I was going for there. So left and right, all of this is fine, but like the problem comes in, like you see that there? When we look, we shouldn't actually tilt. Like it should always be applied as like maybe it's just the ordering. Now see, we're tilting. That's not what we want. Because we're always rotate. I guess because, oh man, we're always rotating on. I really think that we want to apply our look first. And now I'm oh, here. Oops. Yeah, this is broken because it's not actually updating the transform until we move. But believe it or not, this is... Yeah, this is still wrong because... Yeah, fuck. Why is this so... This is such a pain in the ass, man. Wait a second. I think I may have an idea. Well, this may not work, but I think if we force, yep, it is working. So if we always force our look at to use the up vector, then we can never over rotate, or we can never tilt. Basically, the tilt is coming from the rotation relative to the up vector, and when we move, But it is kind of weird because what's happening here is as I move like certain angles, like, yeah, it's not exactly the way it should be. So left and right works, down and that, but if I'm at certain, I think it's because I'm using Euler angles, to be honest. I think I'm hitting one of those weird locks, gimbal locks or whatever. I don't know a whole lot about that. But basically what's happening is I'm looking down now and my mouse is moving like a southwest. Like I'm still moving southwest, but it's pulling me up to the upper right-hand corner. And that's weird. So, I mean, in a way, it's kind of correct, but it's going to be good enough for what we're going to do for now. But we will need to fix this at some point. And actually, what we will do here is, I think, I had something up here before where I was. This wraps okay, so the point of this is to wrap the y axis. As we move down, we start looking down. If our incremental, so what we're doing is we're keeping aggregates of the diffs. So like the x and y that come in here are deltas. Like, so if I move up, it's going to be a negative y. If I move down, it's going to be a positive y, and it's going to be like +1, -1, -2, +1, whatever. And when that happens, we're just adding it. We're just incrementing this mouse rotation y. But we need to check to make sure it doesn't go beyond the width or the entire height of the viewport. That's why we constrain it. Then we split everything in half, and then we come up with the percentage of change based on the mouse being in the center of the screen. And so that's why you can go, we're allowing, really, this is fine because these two things are going to be the same, but we're allowing rotation around the x-axis all the way to -360 degrees, at which point it's going to, I guess at that point it can, when you get here, it's this logic is actually going to flip that to probably this so that you can keep. Anyway, you can keep rotating. I am curious about these. Because This seems a bit much. Actually, let me go back to that problem area. Yeah, it's still happening, but I think that's just a product of using Euler angles, to be honest. I don't really know. I mean, the way that you apply the rotations matters too. So, what time is it? So we don't have a whole lot of time left. I do want to keep this because I think it's helpful. What I don't necessarily understand, what I would like to do is have our rotations actually apply to the existing rotation, existing transform, but I don't think we can do that in the approach that I used with rocks object because we're using all the dirty transform stuff. We're basically calculating this thing at the very last second, which it seems okay. Except for the fact that these things are kind of basically, this is wrong. And so is this, really, because these two things are based on the negative I position. And that is actually, it's wrong because like the transform here is basically it uses the negative I, which is the negative position. And then we're trying to extrapolate the rotation matrix from this, but this is in the wrong coordinate space because this depends on a negative I position, not a positive I position, which these depend on positive I positions. I don't know. Negative I position. Why would it? I don't really know why it does that or why that works, but it does. And the thing is, there's really frustrating about trying to solve the problems that we're seeing, or any of the problems that I've kind of laid out there as being things that we need to look at or address, is that you can get on Google and find a bazillion ways to do this. I mean, case in point, let me not that. That was what I was looking for a second ago. So like, look at this. This is what I tried this earlier. Didn't work. But it has. Oh, this is right-handed. I wonder if that's. So we're doing I minus target. Let's see how we're actually solving that, and then we can see if we're in the same. Where's matrix? There. We'll look at. So I minus target. Well, let's just compare these two. What's up, Colt? So I minus target is going to be our z-axis. X-axis is up times z. And then again, zx. Yeah, so that's right. And then x, x, x across the top. Yep. And then we're going to create our negative I translation and then orientation times translation. So then they come out and they say you can do this. This is essentially the So they turn this into 2 rotations, which is a Y rotation and an X rotation, but this does the same sort of thing where it does a lookup from the Hmm. Ooh. What do you mean? Like over Like, it's better to use vector arithmetic over what? I wonder what would happen if we just did this. This is going to be a lot more expensive, I think, than using Euler angles, but let's just, for the sake of doing this, let's just do this. Let's just see what happens here. So instead of doing this, let's do rotation matrix equals matrix 4 create rotation x. We'll do what? X rotation? We'll multiply it by Y rotation and multiply it by. I think that we need to change the order, though. I think the order matters a lot here. Yeah, it definitely does, because this is weird as hell. Okay, so let's. I think typically the order is Y, X, Z. Nay. Huh. So that's right, kind of. But we got our. Actually, those are flipped. That's flipped, and that's flipped. But interesting. So let's go back here and let's just try to flip these real fast and see what happens. So do that and that. Okay, up and down, left and right. Let's try our screwed up thing where we, hey, So actually, we are in business. We're in business here. This is perfect. This is exactly what we wanted. Whoa. At least I thought it was. I think I rotated 360. Yeah, I did. So when I rotated 360 degrees, which is about here, yeah, it's flipping me all the way around. But that is really weird because that should be fine. I don't know if that's right either. We'll see though. Let's check it out. So I'm going to come over here. Let's go. Why? Why is it flipping on me like that? Did that really? Was it my order? No way, bro. Yeah, it wasn't my order. It was just the. Okay, so let's see here. Yep. So now we're back to our problem again, actually. So it wasn't. It's the order that creates the problem. So let's go back. Let's go back just a little bit. Let's Let's revert back to the Euler angles because it wasn't an Euler angle problem. It's a... Well, it is actually, it is an Euler angle problem, but we can mitigate it by rotating the y-axis first. Okay, and then we can switch back our flipped rotations. So when we do this, yep, our problem is no longer there. But let's rotate all the way around. Why does that happen? I'm so confused as to why that happened. Maybe oops. Let's set this to 0. We might be going off the front end. Let's try the front end. Let's check that too. Wait, what? Are we frozen? I'm not sure I understand why it's popping back. Why is it popping back? Why is it? Let me write out the, let's see, console, right line. Let's write out the degrees here. So x, we'll do look rotation dot x times rocks math 2 degrees, and we'll do y, look rotation dot y times rocks math 2 degrees. Since degrees is a little bit easier to manage in terms of the fuck I'm doing. Okay. Okay, so we're getting over here. Wait, it's flipping at negative 180. Why is it flipping at negative 180? Back to like 60 degrees. What? We need it to span. we're not actually putting it on the right scale. Let me dump this because this is, I'm curious about this. Right line, and we'll do RX, rod X, and then RY, and we'll do rod Y. I need to put the $sign in front so that I can see this, but I think we're not scaling it to the right. Oh shit. Get out of here. Log. I don't think we're scaling it right. I don't think we're putting it in the right number range. That's why it's flipping around at negative 180 versus negative 360, because 360 should be fine. What the? Is this real life? The woes of mouse lock. Okay. Wait, why was that a why is it, this is weird as hell, man. We want to move this thing to the center of the screen. So we're subtracting half of the height. Wait. Well, this is why. This is stupid. This is don't like this is stupid. Wait, really? I broke it like with that? This is nuts. This is absolutely bonkers. Hold on. When we move our X, it rotates around our Y. These are so poorly named right here. It's still wrong, but I don't know why. I don't know why this is fucking stupid. I'm about to get rid of the rotation stuff because it's driving me a little bit crazy. It's basically it's linear right now. So we're gonna take the full delta amount And how do we move it? If we put, what I'm trying to do is move it to the center of the screen. So if I'm basically at, sorry, if I'm at, if I go left -3, then I think what we really want to do is we want to move it to the center by adding half the width Let's just see what this is. So really though, all right. I think this also, it needs to be quarter. It needs to be quarters. It's not right. Like these values don't make any sense to me. That's what's really pissing me off. Is because these will inevitably these will make sense. Let's get rid of these, dumping these, and then like let's show these. I wish it would just put the console window in a reasonably decent place every fucking time, but it doesn't. So, I don't know if you saw that, but basically we can go negative 1024. No, we can go 1012. 1280. Negative 1280. And probably positive 1280 as well. Oh, let me see what our height, we can go to probably 800. Okay. 7, whatever. That's fine. Fine with me. That makes sense. Now, I think what we want to do now I think we want to go back to these values because we want to offset it. Well, no, we want to split it. Fuck. Why is this so difficult to think about? This is stupid. This is stupid. I want to put the fucking point in basically the center of the screen. I want to anchor it in the center of the screen. Then I want to figure out the degree at which I move one way or the other based on the center of the screen. Like what quadrant, essentially. And I want to scale that to basically negative pi over 2, or negative pi and to positive pi for the x-axis rotation, and negative 360 to 360 for the other one. But I actually think that all I have to do this I don't think that I need to anchor it. I don't. I think if we add what we do, because we're allowing negatives, right? Fucking A, why is this so fucking difficult? I think what I had earlier was right. Minus half the width divided by half the width. Or is it divided by the full width? No, it's divided by half the width. Why does it always do that? Just put the fucking console window somewhere where I like last had it or something. See, I shouldn't be getting any values over 1. That's what's pissing me off, is I shouldn't be getting values over 1. I should be able to go all the way to -1. But that... So frustrated. This is like basic math, and I'm... Okay, that was right, but what did it switch from? I got all the way to negative 360, and then it went... Oh my god. Why? Are you... I love how it's still sending me relative mouse coordinates, even though I'm not even part of the... I got a -3... And then it flipped back to 0. Okay, that actually seems right. That's probably what this is for. And these are switched. Hey, look at there. I could go all the way around. Whee! Whee! I think that's what I'm doing. Okay, you shouldn't be able to go all the way around here. You should only be able to go to 89 degrees. This, however, yeah, okay. That's what I wanted. I don't know why that's ridiculous. That it took me that long to figure out what the fucking problem was, because that's terrible. Pi over 2. 2 pi. Okay, anyway, that's fixed. All right, I'm gonna roll for now. I gotta get to real work. But I'll probably do this tomorrow. And tomorrow we are starting Voxel stuff. Period. Like I'm not screwing around with this anymore. In terms of like camera movement or any of that stuff, I'm not screwing with it anymore for now. So tomorrow we're gonna do terrain generation. We're gonna start basically by building a chunk, a quote unquote chunk, and then we're gonna try to from there move to generation. So be here tomorrow because it will not go anything like today, and I'm gonna make sure of it. So thanks for hanging out, and I will see you guys next time.